Good evening, dear students. So today we will be discussing circle in continuation of of our previous session. So today we will start with normal to a circle. Now, before I proceed further, please confirm that someone of you that you are able to view the screen properly and able to hear my voice very clearly.
Yes.
Okay, great. So, what is normal? If I just give you the fundamental definition of normal, is that if you take a curve, okay, uh, if you take any curve, in this case we can take that curve as a circle. Uh, you know, Suppose this is a curve which is a circle in this case, and we take a point, an arbitrary point on this circle. Okay. Now we know that what is tangent to the circle. Suppose I describe the tangent, using the green color. So the tangent will be something like this. This is a tangent to the circle at the at the point P. Now, if I define that point P, the coordinate of the point P as x1, y1, and depending on the equation of the circle, we can find the equation of the tangent in different forms that we are all aware of. If something is not clear, you can look into the previous session, which is available both in the online platform at KonarClasses.com and as well as it is available in the YouTube. Now, what we are going to discuss is the normal. But before that, what I start discussing is that what is normal. Now, the normal to this circle, at the point P, is nothing but a straight line which is perpendicular to the tangent at the point P. That means what? That normal should pass through the point x1, y1, the way tangent, pass through. But the normal should be, perpendicular to the tangent. That means what? If I draw the, normal to this circle at the point P x1, y1, so it will be just a minute. It will be a line like this. It will be a line like this. Correct? So what we say, dear students, is that if this is the tangent, and then it is the normal. Now, one thing is very important to know is that the normal normal to a circle passes through its origin. Okay, that is very important to know and very obvious, right? Because we know a radius is perpendicular to the tangent at that point. So that means if we take the center of that circle at this point, suppose this is the center of the circle, okay, and then this is and if we define the center as the point C, then CP is perpendicular to the tangent. Then obviously the normal which is perpendicular to the tangent must passes to the point C, which is the center of the circle. Now, what we are going to discuss, dear students, we are going to find the equation of that normal. Okay, how to find the equation of the normal? So let us first consider the equation of the circle as x square plus y square equal to a square. So what we are doing is that the circle equation of the circle we are considering as x square plus y square equal to a square. Now, as we, this is the equation of the circle with the center at the origin and having radius a. Now, to find the, equation of the normal to this circle at the point P x1, y1, suppose we take a point P with coordinate x1, y1. So if we, if you need to find the equation of the normal to this circle at the point x1 comma y1, there are one simple step is that you already aware of what is the equation of the tangent, right? That we are already aware of from the previous lessons, okay? And what all you need to do is that you need to make that slope of the normal to be minus 1 by the slope of the tangent, correct? And passing through the point x1 comma y1. So in this case things are pretty simple. In this particular case, because as the normal passes through the center, and in this case the center is at origin. So if this is the equation, then what is the coordinate of the center? Center is at the origin 0 comma 0. Then that's the equation of the normal. How we find the equation of the normal, dear students? So equation of the normal is something like this, that it passes to the point x1 comma y1, so y minus y1 is equal to m into x minus x1. So here m is the slope of the normal. Now how to find the slope of that normal? Because in this case it is 0 comma 0, center is at 0 comma 0, so we can easily find the value of that m. So that is equal to difference of the y coordinate, that is y1 minus 0, divided by difference of the x coordinate, that is x1 minus 0. So from here what we get, the value of m is equal to y1 divided by x1, and that value of m as y1 by x1 will apply in this equation. So what we are going to get, y minus y1 is equal to y1 divided by x1 into x minus x1. Correct, my dear students? I hope all of you got it so far. Okay, so then we can simplify it a little bit and let's see what we are going to get. So this implies is that y into x1, y into x1 minus x1 into y1 is equal to x into y1 minus x1 into y1. So x1 y1 minus xy y1 in the right hand side would get cancelled with the minus x1 y1 in the left hand side. So then what we are going to get here, dear students, so y into x1 is equal to x into y1. So that implies what? That implies x by x1 is equal to y by y1. So that implies x by x1 is equal to y by y1. So I make a complete derivation of the equation of the normal. But as I said few minutes back, dear students, is that if you aware of what is the equation of the tangent to the circle x square plus y square equal to a square at the point x1 comma y1, in fact you are aware of it. If you recall that what is the equation of that tangent to the circle at the point x1 comma y1. So equation of the tangent, if I write, so let me use a different color, dear students. So what is the equation of tangent in the different approach? Actually, equation of the tangent to the circle x square plus y square equal to a square at p x1 comma y1. What it will be, dear students, if you recall, x into x1 plus y into y1 equal to a square. X into x1 plus y into y1 is equal to a square. Let me write properly, y equal to y1 plus y into y1 is equal to a square. So from here, what is our target, dear students? To find the slope of the tangent. So y is equal to what? Minus x1 into x plus a square. Okay, y into, let's write y1. So that implies y is equal to minus x1 by y1 minus x1 by y1 into x plus a square by y1. Correct? Now, what is the slope of the tangent? Minus x1 by y1. Then what will be the slope of the normal? It will be y1 by x1, so that their product should be equal to minus 1. So slope of the tangent is equal to minus x1 by y1. That implies slope of the normal should be equal to y1 divided by x1. So that if you multiply these two slopes, you will get minus 1. And tangent and normal are perpendicular to each other. So then what is the equation of the normal? So from here we can find the equation of the normal. Equation of the normal should be equal to y minus y1. Here we will take y1 is not required because that normal passes through the center of the circle, which is origin. So we can simply write y minus 0 is equal to m. That is y1 by x1 into x minus 0. So that implies what we get, dear students, that x by x1 is equal to y by y1. In this way also you can find it out. I just give two different flavors to get the equation of the normal to the circle x square plus y square equal to a square at the point x1 comma y1. I hope it is well understood, dear students. Very importantly, remember this statement. The normal to a circle always passes to its center. Okay, always remember the normal to a circle passes through its center. Let me write it down as well. Okay, normal to a circle. So let me write it in a different color. Normal to a circle passes through its center. Okay, remember this thing because this is a very important piece of information. Now, dear students, what we are going to discuss is that we are going to find the equation of the normal to the circle, which is a general equation of the normal, is that x square plus y square plus 2gx plus 2fy plus c equal to 0 at the point x1 comma y1 on it. So what we can write, dear students, so let me write it down. How we get it is something like this. So I'm taking it from my the study material. So dear students, if you look into it, that here the equation of the circle is the general equation, that is x square plus y square plus 2gx plus 2fy plus c equal to 0. That is the general equation of the circle, and it passes to the point and there is a point we took as x1 comma y1. Now if we draw that corresponding circle, dear students, so if I draw the corresponding circle, so suppose the circle will be something like this, correct? And that in the normal, what we are going to and let's take the point first. Let's take the point P here. Okay, having coordinate x1 comma y1, and then and let's take that is the center of the circle C. And obviously, as the equation of the circle is x square plus y square plus 2gx plus 2fy plus c equal to 0, what is the coordinates of its center, dear students? It is minus g comma minus f, correct? So now what is the normal? So let me draw the normal in a different color. Let me draw the normal in blue color. So that is the equation of the normal. Now if you see, let me draw it properly. That is the equation of the normal, correct? Now if you look into this now, what we are going to find, we are going to find the equation of this normal. Sorry, let me write properly. Normal. Now this normal passes through the point x1 comma y1. So what we can write, let me derive, then you will find it out eventually that how I come to this, this one, whatever, this one. That what is the equation of the normal? It should be y minus y1 is equal to m into x minus x1. Correct, not your students? Because that normal passes to the point x1 comma y1, and let's assume the slope of that normal is m. But we can easily find the value of m. How we can find the value of m? M is, we can find it because that straight line passing through both the points x1 comma y1 and minus g comma minus f. So what it will be, the slope of that line CP? That should be y1 minus of minus f, because that is the difference of the y coordinates, divided by x1 minus of minus g, difference of their x coordinates. Correct or not? So from here what we get, dear students, we get m is equal to y1 plus f divided by x1 plus g. Correct or not? Now that value of m we are going to apply here. So then what we are going to get? We are going to get y minus y1 is equal to m, we just find it out, y1 plus f divided by x1 plus g into x minus x1. Correct? And then if we just, so from here we took the value of m, apply the value of m is here, and after that if we little rearrange, that y minus y1 by y1 plus f is equal to x minus x1 is equal to x1 plus g. This is exactly this equation, dear students. Got it? So this is the way we found the equation of the normal to the circle x square plus y square plus 2gx plus 2fy plus c equal to 0 at the point x1 comma y1. I hope it is well understood. Great. Now what we are going to discuss, dear students, is that we can solve one question together. Okay, I suggest you that you also open your notebook and do this problem along with me. Okay, and very representative problem. And just to clarify that that we understood all these things very well. So here is the question. Question is that find the equation of the normal to the circle x square plus y square minus 2x minus 4y plus 3 equal to 0 at the point 2 comma 3. Okay. Now what is the equation of the circle? So the equation of the circle is x square plus y square minus 2x minus 4y plus 3 equal to 0. So in these circles, what is the coordinate of the center? The center is having coordinate minus g minus f. So it should be 1 comma 2. I hope it is very well understood, dear students. I don't need to repeat it because x square plus y square plus 2gx plus 2fy plus c. If I give you a side discussion, x square plus y square plus 2gx plus 2fy plus c equal to 0. This circle has center at at the point minus g comma minus f. Now if you resemble with this equation with the given equation, that is x square plus y square minus 2x minus 4y plus 3 equal to 0, you will easily find the coordinate of the center is 1 comma 2. Now so if I give a visual representation of this one, so how it looks like. So suppose this is a circle. Sorry, though it doesn't look like a circle. So yeah, that looks like a circle, and our point P is suppose this is a point P, whose coordinate is 2 comma 3, and this is the center of the circle, that is, let's see, and its coordinate is 1 comma 2. Now dear students, what will be the normal? Normal it definitely passing is through the center of the circle and also passing through the point P. So okay, let me draw properly. So this will be the equation of the normal as I draw in the blue color. Let me draw it very properly. Yes. So this is the equation of the normal. So what we need to find? We need to find the equation of the normal. Pretty simple. There are multiple ways we can do. That first one is that if you can recall the formula, whatever we have discussed, y minus y1 is equal to y1 plus a by x1 plus g into x minus x1, or this one, that if you recall this one, that y minus y1, equation of the normal, y minus y1 divided by y1 plus f is equal to x minus x1 divided by x1 plus g. So if you remember this formula, you can do it. Otherwise, you can find it out. Y minus y minus y1, that is y minus 3, is equal to m into x minus 2. In that way also you can find it out. But in context to our question, what is the value of y1, x1, f and g? Let's do it. Let me do it in this color. Okay, so in context to our, this is the equation of normal, right? That is equation of normal at x1 comma y1. Now in context to our question, x1 is what? x1 is 2, y1 is 3, then g is equal to, we get minus 1, and f is, we get it as minus 2. So then what is the equation of the normal? So the required equation, so the required equation of the normal the required equation of the normal is y minus y1, that is y minus 3, divided by y1 plus f. y1 is 3 plus f, 3 minus 2, that is equal to x. Let me write properly. X minus x1, that is x minus 2, divided by x1 plus g. x1 is 2 minus 1. So that implies what? 3 minus 2 is 1. 2 minus 1 is also 1. So y minus 3 is equal to x minus 2. That implies x minus y plus 1 is equal to 0. That means x minus y plus 1 is equal to 0. This is the required equation of the normal to the circle x square plus y square minus 2x minus 4y plus 3 equal to 0 at the point 2, 3 on the circle. Clear, dear students? I hope it is absolutely clear. Now, the next point what we're going to discuss, dear students, is that tangent drawn from a point outside the circle. So how it looks like, and then we will discuss the equation of the tangent. And there are some very interesting points also I will mention. And very carefully listen to this particular statement what I'm going to make it. Okay. So let's understand. So we have been given a circle and we have been given a point. Okay, interesting, very important, and give a full concentration to listen to this part. So equation of the circle is given. What is the equation of the circle? So symbolically we can represent the equation of the circle is something like that. Circle, now we can give symbolic representation as S, and its equation is x square plus y square plus 2gx plus 2fy plus c equal to 0. This is the equation of the circle. It is given to us. And a point is given to us which lies outside the circle. So the point and the point P lies outside the circle, and its coordinate is x1 comma y1. And that point P, I repeat this statement, dear student, the point P lies outside the circle. So what will be its kind of a if I draw a diagram, so how it looks like. So it looks like something like this. I hope you agree to me that the point P, as you see, x1 comma y1, it is outside the circle. This is the point P. and that equation of the circle, this is the equation of the circle. Now, if you start drawing tangent from the point P to the circle, you will find that there are two tangents. One is PA and another one is PB. Correct or not? So now, what we are going to do now, we are going to find the equation of this PA and PB. Now, dear students, I can tell you one thing, is that PA and PB we can jointly represent. That means it is a pair of straight line. If you recall that pair of straight line when we discussed, during our discussion on straight lines, right? Pair of straight lines. So what we are going to discuss, what we are going to derive, we are going to derive the equation of the pair of straight line representing the tangents drawn from a point P x1, y1, which is outside the circle, to the circle whose equation is given as x square plus y square plus 2gx plus 2fy plus c equal to 0. Now, how to derive it? To derive it, dear students, what we need to do is that we need to make one expression. An expression we need to find it out. Okay, few expression we need to find it out. So already you got s equal to this, so we are going to find s1. Another expression s1 we are going to find, dear students. What is s1? S1 is nothing but whatever you see in the s, this one, x square plus y square plus 2gx plus 2fy plus c. Just expression, not the equation. And in that expression, just replace x by x1 and y by y1. So what the expression you are going to get? It is x1 square plus y1 square plus 2 into g into x1 plus 2 into f into y1 plus c. Correct? Okay. That is S1. So another expression. And the last expression what we are going to find is the T. You know what is the T? T is the expression something like that. X into x1 plus y into y1 plus g into x plus x1 plus f into y plus y1, f into y plus y1 plus c. Now, as if you look into that T, as if it looks like that, it is the expression related to the equation of the tangent to the given circle at the point x1, y1. But that is a very hypothetical statement, because it is impossible to find the equation of the tangent at x1, y1 to the circle y, because the point is outside the circle. Point is not on the circle. How you can find the equation of the tangent? But point is not that. Just to not get confused, I'm just saying this statement. Whatever the T you see, na, dear students, the T, it is an expression. And how to derive that expression? To derive that expression, you need to assume that as if that P is a point on the circle, and I am going to derive the equation of the tangent. You are not going to take that entire equation of the tangent, you take that expression. For example, if I ask you what is the equation of the tangent to the circle x square plus y square plus 2gx plus 2fy plus c equal to 0 at the point x1, y1 on the circle. Okay, let me explain you by means of a different color. So it is just a hypothetical discussion, just to help you to remember. Suppose let's take this circle. So though it doesn't look like a circle, so let's take this circle. Now this is a circle which is represented by the equation x square plus y square plus 2gx plus 2fy plus c. Now on that circle, you take a point P. Hypothetically, I am telling, dear students, and that coordinate of the point is x1, y1. But in actual case, the point is outside. You see, the point is outside here. Now, what is the equation of the tangent? So I am going to find the equation of the tangent. So if I draw the tangent in a different color, suppose I want to draw the tangent in this color. So what will be the tangent? So tangent will looks like something like this. Correct, not, dear students? Maybe it doesn't look like a tangent, so tangent will be something like this. Okay, Now, what is the equation of this? The equation of the circle. Equation of the circle is that, x square. So let me write it down. What is the equation of the circle? It is x square plus y square plus 2gx plus 2fy plus c is equal to 0. That is the equation of the circle and that is the point. So what is the equation of the tangent then? Equation of the tangent, if you recall, dear students, let me write it down. Equation of the tangent will be what? X into x1 plus y into y1 plus g into x plus x1 plus f into y plus y1 plus c is equal to 0. That is the equation of the tangent. So what we are taking only the expression. And what is that expression? That expression is that x1 plus y1 plus g into x plus x1 plus f into y plus y1 plus c, and that expression we have taken it here as t. I repeat, dear students, that's what I said few minutes back, concentrate completely here, that the point P, x1, y1 is actually outside. So it doesn't make sense to find the equation of the tangent to the circle at the point x1, y1, which is on the circle. Impossible. But as we are going to find the joint equation of the pair of tangents, okay, by means of the pair of straight line, so we need to find few expression. One expression is S, as you see it here. Another expression is S1, as you find it here. And another expression is T, as you see it here. And to find that expression T, I just explained all this, other items, that how we can use the concept of tangent to find the value of the expression T. After that, what? After that, task is very simple. We have three expressions. One is S, one is S1, and another one is T. Then the equation of the tangent, the combined equation of the tangent from the point P. So that means combined equation of PAPB. So if I write properly, dear students, so the combined equation of the tangent from P, the combined equation, let me write properly, combined equation of the tangents from P that is combined equation of PAPB, combined equation of PA and PB is given by, very important, S into S1 is equal to T square. That means what? S you know, x square plus y square plus 2gx plus 2fy plus c. S1 you know, x1 square plus y1 square plus 2gx1 plus 2fy1 plus c. And T also you know, xx1 plus yy1 plus g into x plus x1 plus f into y plus y1 plus c. So this expression you need to apply it here. That is the combined equation of the tangents from the point P. That is the combined equation of PA and PB. Now, it is a pair of straight line, so it has to be a equation in second degree on x and y, and that will actually happen, dear students. If you make s into s1 equal to t square, na, you will get it. If you make it in a more elaborate manner, then you will get this, that that it is a general equation of second degree. Anyway, for the completeness, I just write it down here. So let me write it down in a different color. So if I write in green, so if I write this expression, so what will happen? X is equal what? X square plus y square plus 2gx plus 2fy plus c. And what is S1, dear students? X1 square plus y1 square plus 2g into x1 plus 2f into y1 plus c. And what is t, dear students? T is x into x1 plus y into y1 plus g into x plus x1 plus f into y plus y1 plus c. If you look into it and then square, na? This actually, whatever I wrote in green color, that actually represent a general equation of second degree representing the pair of straight line PA and PB together, that is combined. In fact, after the class, you can take one equation of a circle, real equation of a circle, take a real point, and then find the joint equation. You'll find everything will actually be clear if you take one example in the way you want to. Okay, so this is the way we can find out the equation of this one. Now, there is another way also you can find it out, dear students, that combined equation of the tangent. So how? So you can assume the equation of the straight line through P be x1 comma y1. Sorry, the equation of the line through P x1 comma y1 as y minus y1 equal to m into x minus x1. You can do this thing. And you assume let P be the perpendicular drawn from the center on this line. Then P should be equal to R. That is the radius. Condition for tangency. That will give you the value of m. And in that value of m, you can apply in the equation to get that equation of the tangent from P. So just for the sake of completeness, let me give you the alternate method, but I'll prefer that you do the method what I just taught you. But the other way also, you can look into the same problem in multiple ways. So what is the alternate method, dear students? Here it is. Let it come, then let me explain. So let y minus y1 is equal to m into x minus x1 be any line from P. That means what? If I just give a visual representation, it will be something like this. So let me take this one. So as you see that from this point P, from this point P, you just take any straight line. Any straight line from P, passing through the point is any straight line passing through the point P. Now, m is unknown, but how we can find m? Now, from the center of the circle, let's draw a perpendicular. That we can draw a perpendicular. We know how to, draw the perpendicular, length of the perpendicular. We know, we learned from the straight line discussion that what is the length of the perpendicular point to a straight line from a given point to a given straight line. Here point is given, that is the center, minus g comma minus f. And what is the straight line? Y minus y1 equal to m into x minus x1. So you compute the length of that perpendicular as P. Now that P has to be equal to R now, that is the radius. That is the condition for tangency. So if we apply that P equal to R, that will give you the value of m. In this way also you can find the equation of the tangents from the point P. That is an alternate method. Correct, dear students? I hope you got a very clear idea that how to find it out. Okay, we can just
Sir, I'm not able to hear you.
I just give task
So your voice is breaking
and do
from
let me
your
know.